In this video, I'm going to teach you how to solve exponential equations, and we will start with the basics. Suppose we want to solve the equation 3 to the x is equal to 27. Before we apply any mathematical operations, I need you to think of this equation by understanding what it really means by 3 to the x is equal to 27. 3 to the x equals 27 means looking for the value of x in which if we raise the 3 to that value x, the value becomes 27. Okay, so we start by thinking what is that x. So we could check, maybe it's 3 to the 1, but 3 to the 1 is 3. Or maybe 3 squared, but 3 squared is 9. But if you use 3 as an exponent of 3, 3 raised to 3 is equal to 27. So that means the x that we need must be equal to 3. But using that way could take some time, especially if the equation is no longer a simple one. So what will be our guiding idea whenever we solve exponential equations? So another way to look at the equation is, if we have 3 to the x equals 27, we could also think of 27 as 3 raised to 3. Rewriting 27 into 3 raised to 3 makes us recognize that if this is 3 and this is 3, then there's no other way for these two to be the same aside from x being equal to 3. And that exactly is the answer to this equation. X must be equal to 3. This technique uses the idea that in general, for any base a raised to m, if this is equal to that same base raised to n, then we could say that m must be equal to n because a is already equal to a. So we call this technique or idea that we need to always change both sides into the same base. Okay, so for instance, if we simply change the question into 3 raised to 2x is equal to 9 raised to 4x minus 4, then as you can see, it is no longer easy to think of what x to be placed here so that the two sides will be the same. So we will be applying the second technique that as long as we keep the base the same, the base is the same, then all we have to do is to relate their exponents. But this one is a 3 and this one is a 9. We know that 9 is equal to 3 squared. So what we can do with this equation is that 3 raised to 2x will remain 3 raised to 2x, but 9 should be written as 3 squared. And 9, take note that it is raised to 4x minus 4. From here, you need to recall how to work with exponents. In algebra, if x to the m is raised to n, it means x raised to m times n. So we simply multiply the exponents. So this is 3 raised to 2 multiplied to 4x minus 4. And from here, you have 3 raised to 2x equals, so distribute properly, and this is 8x minus 8. Now, we use the idea that if the bases are the same, then it should follow that the exponents must be the same. Therefore, we can continue by saying 2x is equal to 8x minus 8. And solving this equation, we can subtract both sides by 2x, and this is 0 is equal to 6x minus 8. Adding both sides by 8, and this is equal to 6x equals 8. And finally, dividing both sides by 6, cancel 6, and x is equal to 8 over 6. If you reduce 8 over 6, 8 over 6 is equal to 4 over 3, or 1 and 1/3. So this is the x that we need. Okay, sometimes it is not too obvious on what base to use when we simplify the equation. Like for example, if I have 5 raised to x minus 4, and this is equal to 1, what we need to recognize is that 1 can be expressed in base 5 as long as you raise it to 0. So 1 equals 5 raised to 0 means 5 to the x minus 4. And using the same idea, x minus 4 must be equal to 0, and x is equal to 4. So now, what if we have something like 4 raised to x is equal to 1 over 16? So even if the equation seems to be unusual, you always have to go back to the main idea. And our main idea is, if a raised to m is equal to a raised to n, then m must be equal to n, meaning to say the exponents are the same whenever the bases are the same. Now looking at our new example, this is 4 and this is 1 over 16. So you have to find a way how to make the two sides to have the same base. Now we can keep the 4 as 4 raised to x, but you need to think of 16 as 4 raised to 2. And then 4 raised to x means 4 raised to negative 2. Note that I needed to change 1 over 4 squared into 4 raised to negative 2 so that I could clearly see that they have the same base. And now that they have the same base, then we can now say that x, the exponent, x must be equal to the exponent negative 2. So x is equal to negative 2 is the answer for this equation. Okay, so what are the other examples? Suppose we have, let's say, suppose we have 9 to the 2x plus 1 minus 27 raised to x is equal to 0. So as you can see, there is already a big change in terms of how the given equation is written. But again, as I've always said, you have to go back to the main idea that we can relate the exponents as long as the bases are the same. But in this equation, it is essential that you need to rewrite this into 9 to the 2x plus 1 equals 27 to the x. And this can be simply obtained by, we could say, by transposing negative 27 to the x, or more formally, by adding 27 to the x on both sides. And that will make the equation 9 to the 2x plus 1 equals 27 to the x. And as you can see, this is similar now to what we have been solving, or to the examples that we were solving earlier. So again, going back to the main idea, the bases must be the same. However, 27 cannot be changed to 9 directly, and 9 is not advisable to change into base 27. But these two numbers can be rewritten in terms of base 3. So 9 is 3 squared, and this is raised to 2x plus 1. 27 is 3 raised to 3, and this is raised to x. And then, working with the exponents, again, you multiply the exponents. So you have 3 raised to 4x plus 2, and 3 raised to 3x. And from here, we can see that 3 is equal to 3. Therefore, 4x plus 2 must be equal to 3x. and then you just continue working on this equation. This will become 4x minus 3x equals negative 2, and this will give us x equals negative 2, and this is the answer. It is optional to, you can also have an optional check whether your the x value that you obtain is correct, and that is by simply substituting the x that we obtained in one of the equations that we were working on. And say if we have 3, 4, negative 2 plus 2, we are hoping that this is equal to 3 raised to 3 times negative 2. And to check, we have 3 raised to negative 8 plus 2. Is this equal to 3 raised to negative 6? Negative 8 plus 2 is negative 6, and this is 3 to the negative 6. Therefore, they are the same. Okay, but that is something that you might want to do just to make sure that your answer is correct. Okay, so these are the basics of solving exponential equation. Again, the main idea came from understanding that if a raised to m is equal to a raised to n, then m is equal to n. For further note, we use this formula for any acceptable value of a, and that means a should not be negative, and a should not be 0, and a should not be equal to 1. So a must be a positive number. Okay, but in general equations, if you are given equations such as 3 to the x equals 27, or say 3 to the 2x equals 4x minus 4, and then that's 9 raised to 4x minus 4, and even equations like 5 to the x minus 4 equals 1, they all use the same idea that we can relate the exponents as long as the bases are the same. So if the given equation contains expressions in which the bases are not the same, then we have to find a way to simplify them and change them into the same base. Okay, so I hope you now understand how to solve exponential equations.